All right, welcome to Complex Numbers. This is in the middle of chapter 3 of our book, the quadratic stuff. It used to be chapter 4, obviously, but we changed books, so it changed where it is. But this is imaginary numbers. They call it complex numbers in the book. Really, it's our imaginary numbers. So here we go. What happens is, I don't know if you've seen this before, but we got our natural numbers and our whole numbers and our integers and our rational. Anyway, and our irrational, and all of these are real numbers. Back in Algebra 1, if you had an answer that was all real numbers, it was literally anything we wanted to plug in would make it a true statement, even if it was something like pi, an irrational number. You can look up all these later, but we're introducing the world of imaginary, where it's really saying, like, look, there is no way to get this, but if we could, it might look something like this. That's kind of what imaginary is going to do. So if we want to square root 25, 5 times 5, we get 5. Because we had a pair of 5s, and they matched exactly. And that was great. Well, negative 25, if we factor this out, we have this extra negative 1. And we can't do like a negative 5 and a positive 5 because they don't match. So this negative is separate. Well, the 5 can still come out. This is negative 1. How do we get a negative number inside here? Well, this is where the imagination, or the imaginary part, happens. There's literally no way to get a negative number by multiplying the same number together. Positive and positive, and negative and negative. We'd have to have different, both make positive, we'd have to have different signs. So anytime we see a negative under our square root, it's going to come out. It's going to become I. Well, we can do everything else just like normal, but this says, oh, hey, by the way, it was a negative. So this is not really the answer, even though that's how you calculate it. So square root of negative 1 is I. I to the first power equals I. We'll get to this in a second. I squared. Well, anything squared like x times x is x squared. So this is I times I. Well, here's I, and here's I. And square roots like this can actually be shoved together. And then we find a pair. And I had some of my students go, well, wouldn't that just be positive 1 because negative times negative? Normally, I would probably say yes, but the thing is, these imaginary numbers work a little bit different. Like, this was never supposed to be negative in the first place, so we're going to keep operating like it was. So anyway, we find a pair of negative 1s, and so just like the 5s came out on the other one, they're going to come out to be negative 1. So anytime you see I squared, you get negative 1. I to the third means we have I 3 times, 1, 2, 3, and so we found the I squared that came out, and that was the negative 1. We just said that. But this little guy that's left over, well, he looks just like this little negative 1 that got left. So you get an I, and you get a negative 1, which makes I to the third negative I. I to the fourth, we got 4 of them here, and that little guy needs to go away. This came out to be negative 1, pair of negative 1. Oh, and look, we have another pair of negative 1s. These come out. Now, since we're out of the square root, we actually can kind of multiply these together and make it a positive 1. So I to the fourth is a positive 1. So what happens with I to the fifth? Like, where do we go? Well, the good news is, like, this pattern's just going to keep repeating. Because anytime we have I to the fourth power, it's basically worthless to us because they all cancel out, right? So I to the fifth power. We have 4, like we did up here, and we knew all 4 of those are going to cancel out and become 1, right? So I to the fifth has those 4 kind of cancel out, and then we got this little guy left over. Well, when we had this guy left over, he just became I. So let's go what's going to happen here. And I'm going to mark it this way. How many chunks of I to the fourth did we have? Well, we had 1 chunk of I to the fourth. Bam, right there. And then we had 1 I left over. We know that I to the fourth is just 1, so 1 to whatever power doesn't even matter. Same thing with I to the ninth. Something like this. 4, 4, and we got a leftover guy. Well, I to the fourth happened twice, and we had 1 left over. So it works just like this. If I were to add a second one, then it'd be like as if I had 2 left over, and then I'd be looking at I squared. What does it do? So when we get to something crazy high, we know that it's going to fall into like one of these 4 answers: I, negative 1, negative I, or 1. So all we have to do is take our exponent and divide by 4. and then kind of see what kind of remainder we have left, because the remainder is the only thing that counts. Because every whole number of 4 is just going to get canceled out. We'll take our number, divide by 4, and we're going to get a decimal, and the decimal can kind of help match up which one's which. So it looks maybe a little something like this. See the entire page. There we go. I to the 57th. Well, we divided by 4 and we get 14.25. Well, the 0.25 went with I to the first power, because that means there were 14 chunks of 4 that we took out, and then the 0.25 times this 4, your rule of exponent, this is 1/4, so we get 1. That's what happens here. I to the 31st, 7.75, so there were 7 chunks of 4, and the 0.75 is I to the third, negative I. And then we get, and you see the other two, but then we get something even big, 1727, divide by 4, and get this. Well, that means there are 431 canceled out, I to the fourths. The 0.75 is the same as I to the third, which, according to the other slide, was negative I. This introduced the concept of, hey, if you have real numbers and you square root, how do you know if it's positive or negative? Because 5 times 5 is 25. Got that pretty easy. But negative 5 and negative 5 also work. So you got to be careful. This is why when we square root, we put this plus or minus sitting in front. Like, look, this could be either 5 or negative 5. They both work. So here, when we simplify, factor just like normal. And if you need to go back into our factor videos at the beginning of the channel, factor out the negative first, then divide by 3, divide by 3, divide by 3. So this is what I'm looking at. Well, I got a pair of 3s. 3s come out. Fantastic. Negative 1 inside can't stay in there. Comes out to become I. Like, hey, by the way, it's going to be an imaginary number because we can't do 2 numbers to multiply to a negative 27 that are the same. And then this little guy is just going to stay square root 3. Same kind of thing here. Take out what you can. Leave in what you can't. If you take out multiple things like the 2 and the 3, multiply them back together. If multiple things get left inside like the 2 and the 3, multiply them back together. Again, I might be going a little fast, but just pause if you need to. This is multiplication, negative 5i times 3i. And now we have I squared, which, if you remember, I squared is negative 1. So we can actually change that to negative 1 and keep going. I is the only variable you can do this with. If this said negative 5x and 3x, we'd be at x squared and we'd be stopped. But because I squared has some interesting properties in its own, change it to negative 1, keep going. So my final answer is actually 15. Here, negative 6 times, or square root negative 6 times square root negative 15. And again, down here, it's like, oh, well, we have a pair of negative 1s. When they multiply to become positive 1, yeah, but because this and this were never really supposed to happen, we got this imaginary thing going on. And so they operate a little bit different. So pull out the negative 1s. 2 and 5 get left over. Final answer. And this was our homework. Everyone's got a little bit different. But that's the first day of imaginary numbers.